just hit record. And yeah, should be good to go if you want to take it away, Stephen.
Oh. Yes. So I'm going to talk today about Pulseman. So first of all, I'm Stephen Kirk. Like Tom said, I'm a senior software engineer at Toast. I've been here 2.5 years. I've been on the card reader and onboarding teams here. A bit about me, just in the past, I've worked embedded C developer, working in the energy domains and payments industry. Then I moved to the back end, started working on .NET, made my way to Java, Kotlin then in Toast. My email is kirk@tcd if anyone wants to reach out to me after this. Don't really have much of a GitHub or Twitter or any other sort of social media presence. So the overview. Pulseman itself is a test tool for Apache Pulsar. So Apache Pulsar is a queuing technology. I'm going to go into what it actually is in a little bit. I created this tool just to act like Postman, to like send messages and receive messages off the queue, and just store collections of tests that could be shared. So I also worked with Paul Corral and Dublin Kotlin. They had that too. So just give them a mention. So first of all, what is Pulsar? Well, the definition from the Apache website is it's a multi-tenant, high-performance solution for server-to-server messaging, and it was originally made by Yahoo. So basically, you can see here there's a topic or queue, and there's lots of messages on it. You have producers. You can have one producer or many producers, and they put messages onto the queue. You can have persistent queues or non-persistent queues. You have subscribers as well. You can have one subscriber or many subscribers, and each subscriber can have multiple consumers. So these consumers you can have a single consumer, you can have multiple ones. There's lots of different ways. You could have a round robin system where each consumer takes a message and then the next consumer takes the next message. You can have failover. There's lots of different topologies for this. So it's a very flexible system. Toast picked it. They've done lots of load testing, and they picked it as a technology overall to use as a messaging and queuing system. It was low latency. Yeah, lots of stuff that I can't remember from the presentation, but they thoroughly tested it, and it's the one they picked. So we use as our message format, these are messages here on the queue, we use protobuf. So a lot of you are probably aware of what it is. It's similar to JSON and XML in use case, except it's much smaller, as it's a byte format. So you define a message with proto files, like on the right, and they're compiled to whatever target you want. So you can put them to .NET, to jars, whatever. So you need to know the format of your message though on either side of the queue. It's not self-describing like XML or JSON. So with Postman, it's really easy. You just have the string. So it's really easy to send and receive, and you don't need anything in between. With protobuf, you need to have the compiled message on either side. So it's hard to have a generic tool for this. So why I made it. Overall, when you want to test Pulsar, you need the whole pipeline set up a lot of the time. It's very hard to do one part of the queue and just send a message onto it, because you need like hacky integration tests or command line tools to do it. So it's also for QA. QA can't just jump in. They need to wait until the whole flow is finished. So it's handy to have a tool like this. It's useful as well to document, like with Postman, how your Pulsar topic works, how the messages are created, how to send, and what different message formats are. So the other main thing is there was no graphical tools for this on the market at the moment. I haven't been able to find any. There could be at this point, but I couldn't find any anywhere that did something similar to this. So I'm just going to do a demo to show it first, just to give you context for everything else. So this is the tool itself. So you've got separate tabs for all your tests. Just have your tab name, then your topic. So the topic is the name of the queue. You have a little search functionality here. This currently only works on unauthenticated connections, the actual select topic. So it will query your Pulsar cluster just for all the topics, and then you just pick one of these and it will fill that topic field. Then you have just the definition, just the service URL for your actual Pulsar cluster you want to connect to. And you then have all the jars. So in Toast we compile everything to a jar. all our protobuf messages. So you put in your messaging jars, your authentication jars. So because this is going to be open source, I couldn't just keep in the Toast authentication, and other people might want to add their own authentication formats. So if you create a class that uses the Pulsar authentication interfaces, you can supply your own authentication to this, and then just any other jars you want for serialization, deserialization, and authentication. So I would much rather have a nice Maven Gradle type approach for this, but I need to figure out how to do that. I couldn't find something easy and quick to do. So for now, you add the jars to the project. The one handy thing for this is it's really portable. So the project file itself is just a zip file that contains all the tab settings and the jars. So you can just hand it to anyone and they can test straight away. So once you have your jar set up, I don't want to show off our auth settings, so I'm just going to switch tab. So once you have your auth set up, you can either use auth or not use auth. If you have lots, you can just filter. So no classes loaded. And then the cool thing about the interface that Pulsar provided is it allows you just to provide a string, and you can have the string in whatever format you want with the settings. So this is the format we use in Toast, client ID, client secret for auth. So you can supply that. You can put in whatever format you've created for your auth. So properties then as well in Pulsar. These are kind of like headers in like a REST request. So we use this. So this is a list of key value pairs you can set. So we use this just to identify the message that's on the topic, so we know how to deserialize it in Toast. So if you actually want to serialize a message to send, you go to class, you pick the class you want to serialize with. So we support two message formats at the moment for Proto 3. So the Google generated message v3 and open source format from Toast called Proto KT, which is it's a Kotlin DSL wrapper for Proto 3. So in this case, I've selected background. This is the background check service in Toast. I'm going to send with, I'm going to receive, I'm going to monitor the same topic just to see the message was sent correctly. So I can try decode with multiple formats. So I'll try background check result as well. So I'm going to, this is Kotlin code. This is Proto KT using the Kotlin DSL. I'm going to compile it. So that's compiled and it's gone to an array of bytes. I'm just going to send. So it's all done dynamically at runtime, so it can take a while to actually send. So that's sent, and then I'm going to. So I was already subscribed actually. So let me just clear that and send again. Send. So we just 678 EE 678 is at the end here, because I've deserialized the two formats I had there. And you can see 678, it's deserialized it, and it's also shown the properties in the headers. And then this one failed to deserialize because it's not the correct format. So what else have we got here? Yeah, so there's also just generate, so it'll just give you a template for the class you selected, so you can fill it in quickly. There's also just the menu up here. You can save a project, load a project, and copy the current tab just to quickly, yeah. Going to extend this to make it better as I go along. So back to the demo. So why did I pick Desktop Compose? Well, there's the alternatives. So there's React Native and Electron. I really need this to be on the JVM because all of our compiled jars are jars, so it's just easy to have everything on the JVM. And I don't want to program in JavaScript. Swing. I could have used it. I'm sure it would have been great, but it's pretty old. And I wanted to use, it's not very tightly coupled with Kotlin. There's Tornado FX, which is a Kotlin wrapper for Java FX. I did write, actually, I'll just show you. I wrote my first iteration of this in Tornado FX. It was okay, but yeah, I'll get into it a bit now. I'm sorry. So like Compose, it was really quick to get set up with the UIs. It's all a declarative way. You don't need to have any XML or anything. It's all in code. Support was a bit easier to find online. There's a lot more support for Java effects online out there than Desktop Compose at the moment. It's still a fledgling technology. I did find state in tornado effects quite awkward. There's lots of observers and subscribables, and it took a lot of learning to do it right if I wanted to use a set over a list, for example. And I didn't see a lot of active development on the GitHub repo, so I was a bit reluctant. Currently, the original Tornado FX is stuck on Java 8. There is a Tornado FX 2. I think that's going to be targeting Java 11 and up. I don't really know the politics that's going on in the background. I'm sure it's to do with licensing or something. But in general, I didn't see a lot of commits on that branch either. So it didn't really fill me with a lot of confidence as a supportive technology. So why I made it with Compose. So I need this project to run in the JVM on Kotlin. Mostly because, I wanted it to run in the JVM on Kotlin because Kotlin is the standard language in Toast. So internal contribution. All of our current protobuf definitions in the company are compiled to jars, and I'm good at Kotlin, so it was easier for me. It's also really good to cross-skill in Android development. I've made apps in run-of-the-mill Android before, but I can't see myself using it in the Jetpack Compose in the future. So it's really good. There's also good multi-platform support. I'll go into that later on. And it's supported by JetBrains and Google. Google for Jetpack Compose and JetBrains for the desktop. So I don't think this is going to die anytime soon. Downsides, it's still in constant flux. I'm surprised some of the stuff that doesn't work in some of the early builds. Things like I've got listed here, the selectable text. You couldn't select text in a lot of the components. You'd move, if you've got dual monitors, you move to another screens, all your UI breaks. You can embed swing in it, swing components, and they just don't resize properly. Like for all of them, all my issues got fixed just by upgrading the version. I spent ages just trying to figure out what I was doing wrong. It's also not as fully featured just as the competitors yet. Like things you'd expect, like file dialogues and stuff, aren't built in. So it's getting there, but it's not ready for fully ready for showtime. So just a quick compare of how you actually do GUI elements in Jetpack. So this is the Tornado FX approach. So you've got like a V box, which is like a vertical box. Then you put a button in it, and then when you have an action for when it's clicked, and then that action's done. Pretty simple. Jetpack Compose, Desktop Compose, pretty similar. You have a row. It will be a row like this. Just put in some text. I've got an icon button, and you have an on click. It does what's in the on click. Pretty simple. So what Compose Desktop does for you. So you can leverage all the core Jetpack functionality, and then there's some desktop add-ons. I'm going to just go through all of these and how I use them. So it's got the click modifiers, keyboard events, enter, exit, integrations for the menu bars and trays, app icons, notifications, sign and build-in for Mac. Yeah, I won't go through all that. And like I said, you can use legacy swing components, which is really handy. So swing integrations. So for all the code elements, I used or syntax text area, which is a swing component. I used it for JSON like here, and I used it for the Kotlin code. I actually used Java syntax because they don't have Kotlin out of the as a default language, but you can create your own syntax parser. It wasn't worth the effort. I might go back and do it, or maybe hope to create one going forward. So one of the problems I had with this, I'll show you how I use it first. So you define your text area and your scroll pane, which is the swing component is the SP here. Then you have a compose box, and you just use a swing panel, and then have your own J panel and add the swing component. It's really simple. You just instantiate it and put it inside the swing panel. It was very easy to use. So this is one of the problems I had, which was resizing. I resized the screen, and it just doesn't resize with it, the swing component. You need to close the tab and open it, but it's working now. It actually was working originally. It broke, and now it's working again as I upgraded versions. So like I said, stuff's changing rapidly on this. So there it is, resized correctly. So there's another way as well for integrating swing components. So this, I didn't have a file chooser out of the box, so I used JFileChooser. So you instantiate your swing component, which is this file here. And then you need to go to the Compose App Manager and just get a JFrame. And you just pass the JFrame to the swing components, and that's it. It just starts off really, really simple. So you file.show open dialog, and you pass the JFrame in. So the enter and exit events. So if you go into the X button here, if the circle means unsafe changes. If you go in, X is shown. If you go out, X isn't shown. So that's all done through modifiers in Jetpack Compose. So you add your clickable, that when it's clicked on, it'll close, and you've got your on enter and on exit events. You just change the value of the image that's being saved when you go in and exit. So not hard. Middle clicks. There's not a lot of support for anything except a left click at the moment. So if you want to catch up any of the other events, you have to parse them all. So once again, you have a modifier on this surface. So you're parsing through all the gestures. You're checking if it's a mouse button event and if it's equal to the middle click, and if it's pressed, and then you close the tab. So this allows you to close the tab with the middle click. It was a little awkward to get. Well, Paul actually got this working correctly, not me, but yeah, it was a little awkward to do. So the menu bar integration, you can have shortcuts in it as well. Save, load. Once again, there's a few ways to do this. This is the simple one I use, which is the app manager, the Compose app manager. You just go set menu, you put in menu items, and then on click, you do whatever action, and you can put in shortcuts. So I couldn't find a way to do more advanced shortcuts. Maybe they've added it at the time, but I could only do single key shortcuts when I tried at the moment. So hopefully they'll make that so you can have like Shift S for save all or something like that. So I have no on click for save as at the moment. So tray icon, you can put images on out of the box. This didn't seem as easy to do in Tornado FX. All these customizations, Jetpack have really made it easy. Sorry, Desktop Compose have made it easy. So in this case, you just have your app window and you just supply the icon. You have to have a buffered image, which is a bit annoying. There's no way to supply a PNG directly to it. And all the examples were kind of contradictory at the time. I hope they've updated their documentation. These few lines took a while to figure out. You can set the app icon. That's done in the build.gradle file. So you just point to a Pulsar. It's an ICNS format. I just use an online converter to create that for my other icon. So sign in and notarizing. So Mac is really annoying in that you can't just build the app and distribute it to people you want to. So specifically for Mac, you need to create a bundle ID, which is just like your the Postman format. On your developer account, you need to set sign in to true, and you need to generate a developer ID certificate from the App Store. So this is just putting your account name there, and it'll find it in your key registry. The sign in just identifies it correctly from a file account, and then it notarizes it and it just checks it for viruses or whatever on the Mac side, with an Apple ID and a password from your account. You can put the password in your keychain as well if you want. So yeah, you can also in your build, you can have specific build settings for each target. So Mac, Windows, and Linux here. So multi-platform. I actually haven't used this, but I'll just show you from one of the samples on the Desktop Compose website. So if you want to share with Android and desktop, for example, there's two main keywords you can use: expect and actual. Expect is what you mark up like any piece of code, like a composable function, and you expect this to be implemented in different specific implementations for each platform. And then actual is you mark up the actual implementation with the actual keyword. So here's a very contrived example from the Desktop Compose website. So we've got this home folder that implements the file interface here. It's got an expect. So then you have an actual. So you've got the Android implementation here, actual file home folder. So that's a late init. So that'll be just assigned somewhere else. And then you've got the Windows one, which is just going to get a system property. Desktop one, which is going to get a system property, and just implement that home folder as well. So it's pretty intuitive. So you can, like I said, you can mark up composables, functions, classes, whatever with these keywords for multi-platform. So the app itself, it works using three main things, which is reflection, the Kotlin scripting library, and I'll go through the authentication as well. So to load the classes at runtime, I'm using the reflections library. And to actually load the jars, I'm using the Java URL class loader. So to load the classes, you just supply the jar file, and you pass that file into a URL class loader, which is just a standard Java class. And then you pass that class loader into the reflections library. So the reflections library is an open source project. So, and you just filter on the class type you want. So this saved me a lot of effort. I spent a lot of time trying to manually do this, but yeah, should have just Googled earlier. To actually load the jars at runtime, I extended the URL class loader class. So you just supply your URLs to your file, you pass in the system class loader to the class, and then you just access this protected add URL. Now, this doesn't actually add jars to the system class loader. It only adds them to this jar loader. So you have to actually use the jar loader to instantiate any classes to have access to all of these loaded jars at runtime. So serialization is pretty simple. Once you have your you have your generated class from the Kotlin scripting, you just call the interface to byte array and it serializes it. This is for the generated message v3. It's similar for the ProtoKT DSL. I'll probably make this a bit more type safe and get rid of any here. The deserialize as well. So you've got that jar loader you've created earlier. You're loading the class, your deserialization class, and you're going to call the parse method. So this is just reflection in general, how to call a class at runtime. So this is a static class, so you don't actually need to provide a class to use. It's null, and you just pass the bytes to the parse from the function. So you'll notice here as well, I'm catching throwable and not exception. That's because you could have a missing jar at runtime, and that throws an error, not an exception. And people are going to be adding and removing jars to make it work. So it's just better to catch throwables everywhere, which is bad practice usually. So Kotlin scripting. I'm generating all the code at runtime using the Kotlin scripting API and the JSR223 specification, which is a specification for the Java scripting engine. So this is all the code it took. The amount of Googling to find examples of this is not done. There's not a lot of examples of it anywhere. I think the most of the work was just finding the imports for the Gradle file. So you load the script engine manager and you load the Kotlin extension, and then you just pass your codes into the engine. So whatever you compile, the last value is that you have is returned out of this eval to this class. So I'm passing all my loaded jars into the script engine. I thought that would work. It actually didn't. So I had to actually add the jar loader to the threads class loader to make it work properly. So I don't know if that's a bug or I'm using it wrong. So how I did authentication. Pulsar has these two interfaces, the authentication interface, the Apache Pulsar project, the authentication interface, and this parameter support one. So this is for command line authentication. So you can just go configure and pass a string, and it authenticates any request you have. I'm very lucky to have this, or it would have been quite awkward to do in a generic way that anyone could use. So this is an example of an authentication basic class from the Apache Pulsar project. They have the configure class. It takes a string, which is in JSON format. They just decode it, get the user ID and password. So that's just standard basic authentication. So mistakes I did in general. I didn't know how to do a Jetpack at all before I started coding, which was, I should have done a tutorial. I wasted a lot of time. I'd suggest just doing the Android tutorial even, especially just to get a handle on the state management. Also, if you go to the Desktop Compose Git repo and look at the tutorials, they've got really, really good tutorials to show you all the desktop functionality. I was really impressed, and they're updating it all the time as they break/change everything. So like I said, my biggest mistake was not understanding the state model. I got lots of bugs because of this. So I'd have a class, I'd have all my state stored in the class, and I'd have my UI composable inside the class. So it's better to keep your composable. So you mark up any UIs with the composable keyword that you want to show, and you should keep these as stateless as possible and pass all your values into the actual function. Don't do this, because if you have multiple instances of your UI component, it all gets confused. If you change one version of the UI, it might update the other one. This remember keyword, you just work around. You can put a key value in this remember to work around it. But I had loads of really odd bugs. So you're better off doing. You'll see this in the initial tutorials as well. So this is why it was a stupid mistake. So you're better off just pulling all your state into a class and passing it in. And if you ever have any changes, just call it an on change. It's a lot of messy stuff. The great thing about Kotlin is data classes. I mean, you have to do stuff like this. It's a little annoying, but it will save you a lot of woe. I'm sure there's probably an amazing design pattern out there to do this nicer, but I've refactored all my code to be like this basically. Everything's just read only what I pass. There's no mutable values passed in. So my plans going forward are I'd like to make it open source. So I'm going through the process internally in the company at the moment. And I'll add a link to the user group once that's done. I'd also like to add JSON. So JSON would be really easy. That's just a string. I can probably do that in a couple of hours easily. And maybe other formats like Avro to this tool. So that is all for me. Any questions?
Brilliant. Thanks very much, Stephen. That was brilliant. Really enjoyed that. Very interesting topic and yeah, well done presentation. Yeah, cool to see the kind of swing Tornado FX desktop evolution, and yeah, feels like a big jump to desktop for Kirk Compose for desktop, I should say.
The making the UIs, like it's similar, but it's definitely better in Compose. Yeah, I find it much easier, and you've got material teaming as well from default, so it looks a lot smoother and cleaner out of the box. It took me a lot of time to get spacing right in Tornado FX. It reminded me of the old working in .NET, the old I can't remember the WinForms projects. Like it's very reminiscent of that.
Mm-hmm. Okay, and can it run across like Windows, Linux?
Yeah, so it can work on Windows and Linux and Android. I just need to. I haven't tested on Windows. It's probably mostly work on Windows right now. I just need to test that. Not sure about Linux. It should be fine. Okay. So that'll be my next thing. Get working on Linux and then maybe Windows. And probably not worth doing anything on Android for this, to be honest.
Nice. Cool. So, question from Luis, I think. Did you use Kotlin coroutines?
I did. I use Kotlin coroutines. Yeah, you don't get any of that out of the box. So let me just share. So when I go subscribe here, that's a Kotlin coroutine, and that button is going off. It's waiting for the response to come back. It's fine. I can switch around. Nothing's getting blocked. It's working grand. That subscribe's taking a bit too long. Am I still connected to the pre-tunnel? I am. Okay, we'll ignore that. It's working perfect. But yeah, so yeah, I use coroutines everywhere. Okay, so there's something wrong. I must have changed my oh sorry, I'm in the wrong. There's no context set up there. That's why there's no all settings set up in that tab. That's why that didn't work. So if I go here, subscribe. I didn't change tab, sorry. Subscribe. It's gonna hurt. Yeah, subscribe. Yeah, so yeah, absolutely everything in the tabs is done with coroutines. It works really easily. One of the changes I'm going to do is probably create a global coroutine scope. I've got it all local to each tab, just so it's easy to clean up as I exit. Yeah.
You're going to change to global scope?
Yeah, just so when someone closes the app, it'll just clean up all the Pulsar connections and everything like that.
Okay.
Easier. There's a lot of manual cleanup at the moment. The coroutine scope will probably just cut all that code down.
Okay.
Nice. I have to use futures though, because the actual Apache library uses futures to return the subscription results. So I only use that where I have
to. Is it the Java, is it all embedded in the app, or is it using any Java on your machine or anything like that?
Yeah, it should just well, as long as you've got Java on your own, you will need Java on your own machine. Yeah, it's targeted in Java 15 at the moment. I have to do some testing around deploying it to computers that don't have Java bundles. So that'll be my next step. I had a few issues in the development environments when people are pulling it down, but I think I've got them fixed now. It's just not a lot of people have Java 15 loaded.
Yeah. Cool. Yeah. Any more questions from anyone?
Cool. If you're vetting later, I'm happy to reply. Thank you.
Awesome. Thanks again, Stephen. That was really good. Cheers. Cool. So next up we have Justin. If you want to take it away.
Cool. Are you guys able to see my screen?
Yeah.
Okay. So hi everyone. Thanks for joining tonight. Me talking about Jetpack Compose, and I'm going to be taking this more from kind of an architectural perspective. So I'm sure a lot of you are working on Android projects and are excited to get Kotlin Compose in. There's obviously stacks of documentation out there for how to, basically how to use Kotlin Compose. What I've tried to do is present based on, how do you migrate over? What are the things that you need to consider? That sort of thing. So to kick off, so first of all, just about myself, Justin. I work at Vhi Healthcare, the mobile app architect. I oversee the Android and iOS applications. So a bit about the app. So I kind of kept this only on the Android side. So we launched in 2016. So the app's been around for a fair amount of time. We've got over 100,000 downloads, and we've got a 4.4 star rating. This is also a very big app with over 200 screens. So that in itself brings its own challenges. All right. Okay, so just a bit of background on Jetpack Compose. I'm sure you guys know all of this already, but it's about Jetpack Compose. I kind of had to put these slides in. So Jetpack Compose is a modern Android UI toolkit. It was obviously introduced by Google Android. It piggybacks off of the Kotlin Compose work in the background, which is really helpful. And basically in 2019 at Google I/O, Google basically announced Jetpack Compose for Android. What was a little bit different with this set of libraries that they plan to develop is they actually developed it out in the open. They released the source code from the get-go. This approach was super helpful because they could get feedback from developers earlier and adapt the library accordingly. So I mean that's super helpful. From our perspective, though, they released it, or when they released it, it was a bit too early for us to take a look at it. So we kind of put it on the back burner, knowing that this was something that was going to come down the line, but we didn't take too much notice until this Google I/O when they actually announced the release date. So version 1 is set to be released at the end of 2021. And so obviously now is the time that we've kicked off looking at, first of all, if we're going to migrate, and yes, we are. And secondly, just looking at that whole migration process. So some of the benefits of Jetpack Compose. So one of the big ones that I enjoy is the fact that your code base is going to be about 100% Kotlin. So currently in a typical Android project, you're looking at about 20% XML layouts and about 80% code, which hopefully at this stage is in Kotlin. And then probably less than 1% of configuration, like build.gradle files, etc. So with Jetpack Compose, with the UI being Kotlin, this basically means that you're doing everything in Kotlin. The XML layouts are not super complex, so it's not that much of a cognitive load, but still it's one less thing you have to kind of learn, especially if you new to Android development. It simplifies the development process. It uses less code, and as a result, less potential bugs. The uses less code, and going through the kind of proof of concepts, which I'll get to a little bit later. That's one thing that I've actually noticed, where a lot of our classes where we're just kind of interacting with the XML layout, replacing it with Compose has actually kept the lines of code, pretty much the same, slightly less, but then you're taking the XML completely out of the equation. So definitely, a lot less code. And there's certain things, like lists where there's definitely a lot less code. The way that Android structured it is unbundled libraries. This is super awesome that, you can take the bits of Compose that you want, and then also the fact that they've developed this externally to the kind of normal SDK is pretty awesome. So you've got backward compatibility, you've got, you're not having to wait for a yearly updates. They'll be publishing updates quite frequently. Then another benefit, bidirectional state. So this is one thing that Android's kind of been missing out quite a bit. There's a lot of frameworks out there that have that bidirectionality. And I mean, with if you think of things like data binding, you kind of got that one-way unidirectional state. So this is great that you actually have that bidirectional state. So a couple other benefits. Animations are super easy to do. I was quite surprised at how little code it actually took to do some of the animations that we do within our application. And it really kind of lends itself towards being able to create a user interface that not only looks good, but then that animation aspect just brings kind of like a really good feel to the app. Another thing that's great benefits is Jetpack favors composition. So some of you that may have kind of extended views before, that inheritance structures is not great. And then also Compose works on desktop, as we just saw now. So, again, from an Android developer perspective, you can build something in Android and you have the skills that you need to build something for desktop, which is really cool. And then also dynamic theming. So one of the big showcases that they had with the whole Material U is they take basically a color from your background and they basically customize the UI based off of that. And with Compose, that's super easy to do. So I never like to only look at the positives of a library. Maybe it's traits of an architect. There are obviously drawbacks, and the drawbacks is it's a new library to learn. More importantly, for developers, Android developers that are used to the kind of pure XML, find view by ID, adjust, get values, set values, that sort of thing. It is a new programming paradigm, having a state that drives your UI and then updating that state. So, for some people that aren't familiar with that, they may struggle with that in the beginning. But as soon as you kind of get that programming paradigm, it's actually very intuitive and it's very helpful. One of the other things that's a bit of a frustration, and I suppose it's just something you get used to, is, you know, with the old kind of Android view system, you had a lot of internal state that was handled for you. So for example, a text view handling, you know, the text that's contained, that, you know, a user, sorry, I actually meant not a text view, an input field. You got to manage the state of that input field. So as the user types in information, you got to store that state somewhere, and you need to actually display it on the input field. And likewise with the checkbox, you can't just kind of query a checkbox to say, are you, you know, selected or unselected? You've got to manage that state. So sometimes with a few of the components can feel a bit cumbersome that you have to handle that internal state. But again, it's really something that you need to just get used to. So I'm going to run through the architecture of our app, just to give you guys a bit of background, and then we'll kind of run through, you know, how we're planning to implement Compose. So at the top level, our app is modularized. So, you know, essentially each feature is its own dynamic feature, dynamic delivery module. We do this for a couple reasons. One, our app has a lot of functionality, but that functionality is sometimes tied to what policy you have. So we don't want to have a massive APK size. We want to be able to kind of configure the app for your particular policy and not have you download things unnecessarily, update things unnecessarily. So basically everything's done in features. And then within each of those features, we follow the clean architecture. And, you know, basically each of those modules are then split into 3 modules for presentation, domain, and data. And, you know, would use interactors and repositories and, you know, all the typical kind of clean architecture bells and whistles. We keep our domain levels kind of as much kind of library agnostic as possible. Although, you know, they're Kotlin, we use coroutine, so there is a bit of kind of dependency there on external libraries. It's not just a plain old you know, Java project or a plain old Kotlin project. Then on the presentation side, so currently we, you know, basically follow an MVVM pattern. So you'd have the XML UI that kind of interacts with the view, a view interacts with XML, and then from there the view subscribes to changes on a single state live data object. And, you know, basically if we need to do, for example, a network request on the click of a button, the click of the button would happen on the view. It would forward that onto the view model. The view model would forward it onto the interactor, and, you know, the chain would return, except over here it would be updating a live data state and going back. So our current architecture lends itself quite well to migrating over to Compose, because we already have a state representation. Although there are definite differences between the state representation that we need for Compose versus what we have at the moment, but still at least the infrastructure is there. Okay, so very broadly, the migration plan, and this is pretty much a standard template for you know, anything that we look at. So the first portion is investigation. So figuring out, you know, is this library really gonna bring benefit for us as a project? And I'll give you an example. Android announced Hilt and, you know, recommends Hilt and all of that sort of thing. But during the investigation process, we found that you know, Hilt only works on your base module. It doesn't work on any of your feature modules. So, you know, something like that we decided not to go for in the investigation stage because it really doesn't bring value to us. Then the second portion is So once we kind of know how it can work, we just standardize the way that we want it to work in the project. So obviously we've got a fairly big team, and what you don't want in a big code base with fairly big team is everyone to do their own thing, because that just gets messy and unmaintainable very quickly. So the standards portion of it is really just kind of define how it should work within our project. Then basically would normally take the strategy of any new work will be done in that particular way. In the case of Jetpack Compose, all new work will be done in Jetpack Compose, and then kind of modifications to existing work in the beginning we'll kind of take it on a case-by-case basis, and as time progresses we'll basically make it a rule that any class that you touch, if it's not using Jetpack Compose, convert it first before doing the work. And then we would need to just have a strategy on the old work. So where we are at the moment is kind of the tail end of the investigation. So we've kind of proved that this is something that we want to use going forward. The main thing is obviously less code. Initially, there's quite a big overhead for us, at least, building out components that we use, common components within the app, building out our theme, all of that sort of thing. But once we have that initial kind of scaffold set, then moving forward, development should be a lot quicker and easier to do when it comes to UI. Right, so just the approach that we took with the investigation portion was we wanted to do a couple proof of concepts. So looking at some common elements within screens, common areas that we wanted to, just figure out how does this work, and is it going to work for us? So the things that we took were obviously, the theming is quite important. So with regard to, the theming, material gives you quite a good out of the box theme. And we basically follow material within the app. Obviously the designers have kind of customized materials. So a lot of that investigation work was really just figuring out, how does that work? For example, we have a color palette that's bigger than the standard material color palette. So there's it is possible for you to have more colors within your material theme colors, but there's some work that you need to do in order to create your own kind of custom color palettes and basically utilize that color palette. Then in terms of form inputs, so this was a big one for us. Again, just taking a look at input forms. You have to manage the internal state of your fields as users type it in, all of that sort of thing. And at the same time, you need to basically be able to format that into a data object that you're sending over to an interactor, which inevitably goes to the API or whatever. So, just handling things like, validation, handling things like just the pure data type. One of the issues that I kind of ran into was that we needed to basically just input a integer, and you could set the keyboard to essentially have the number keyboard, so it's limiting the fields that can go into it. But that keyboard still has decimal places, it still has commas, it still has a couple extra keys. So initially, with the straight conversion of how we were doing it before, we had basically taken the value, converted it to an int, stored that int, and then displayed that int on the field. But as soon as someone types in a comma, when it's converting to the int, it crashes. So what we found there with form inputs is it's a better approach for us to, basically have our view state in kind of like a string type field. And then when we get to the validation, actually validate that we don't have, weird characters and all of that sort of thing. Lists. So we went through, we took a couple areas where in the app where we're actually displaying list values like recycler view type data. And that becomes super easy because you don't have the adapter. And actually just reading the source code sometimes was a bit more helpful than reading the actual documentation. And one of the nice things is they've actually structured Compose with eloquent Java doc style comments. So reading the source code is actually quite easy to do. So images, this is another one that one may not take into consideration in the beginning, because you're thinking of all your standard kind of layouts, but most projects have remotely stored images that they're most probably using Glide or Coil or something like that. And once you kind of get to that point where you're like, well, actually I need to pull this image and put it into Compose, that's the point where you figure out very quickly how dependent you are on Glide and Coil and those sorts of libraries. So luckily with that and the Shimmer, there are libraries out there that have already kind of built in a base implementation. There's actually a library, I forget offhand what it is called. I think it's Accompanist, which has basically done a port of Glide and Coil for images. And if memory serves me correctly, they've also got an implementation of View Pager. So there's definitely libraries out there as it stands, and I think as time progresses, the items that don't have libraries will definitely get libraries built into them. Another one that we use is Markdown, which again, it's similar case. We kind of had to just do some research and find a library that we could use that would display Markdown in Compose. There's a couple options out there. Also, because Compose itself is not in production, obviously none of those libraries are kind of 1.0 in production. So depending on the policy within your company, for us, for example, we can't release items that are non kind of production ready. So that's also one that was a bit tricky for us to deal with. And then custom views. So I mean, this doesn't come up very often. Well, in my experience, it hasn't come up very often in projects where I've worked on, but almost in every project that there would be at least one view that would be something that I would have to do like very custom, basically getting into kind of the canvas draw commands and all of that sort of thing. So what I've found so far, Compose obviously supports that, and the interface seems very similar to the the old kind of view canvas and drawing. And if you kind of command click into a lot of the elements, you'll actually see that deep down it's actually using that same kind of canvas drawing mechanisms. So I haven't got to the point where I've converted one of our custom views, drawing it with Compose, but I'm quite interested to see what actually happens there. Okay, so basically the way that we're going to structure it within the app is so at screen level. So we've basically got 3 levels that you can have composable. So the way that we're looking at it is, you'll have kind of a view composable, and that's basically a composable that's very specific to that view. It's not going to have any reuse. But then for us on feature level, sometimes we have certain elements that are kind of displayed a couple times within a feature, but it's specific to that feature. So we're going to have kind of the composables, basically at feature level, and then obviously app-wide components. We're going to have so we're going to have those 3 levels of composables, and again, that's dependent on the project, dependent on the architecture, and all of those sorts of things. But just to give you an idea of the approach that we're going to take. Also, I don't have a slide for it here, but what we've done is we've kind of separated our theming and our components. So that's quite helpful in the sense that you've got your theming, which is obviously your colors, your dimension metrics, your shapes, your typography, all of that sort of thing, all kind of wrapped, enclosed in one component. Yeah. So as we kind of said, once we get past the investigation point, which we're at the tail end of, we kind of go into getting production ready with Compose. So the first thing is just defining those standards, the list of do's and don'ts with Compose. We've got code generation tools, so each screen basically gets generated, or the scaffolding at least gets generated, so that it has the view model, and before it had the XML layout. So obviously we need to update those code generation tools. The approach that we're going to take, I'm jumping a bit forward here, but the approach that we're going to take is basically so there's interoperability that allows you to use Compose within XML layouts and allows you to use XML layouts within Compose. We're not going to go to that level because I feel like that's going to end up being a little bit more messy if you've only got certain elements in Jetpack Compose, but you have your overall layout in XML. There are certain cases where we may do something like that. For example, if we're using a third-party library that's exposing a view to us, that lends itself quite well to us. The approach that we're essentially going to take is for each screen, it's one or the other. Either it's an old screen and it's in XML, or once we go through and we create a new screen, the entire screen is going to be in Compose. Right, then also just in terms of theming, so for us, we're just going to make sure that all of our kind of base level theming elements, so all of our colors are there, all of our dimensions, all of our typography. You could take the approach where you add it as you need it, but we're just taking the approach that we're going to kind of take the knock, put the scaffolding in, and then moving forward, it's super easy for us to use. Also, there's a couple cases that I found already where we would need to kind of create some support utilities. So for example, at the moment, if you want to get text from a string resource, you've got to utilize the getString function to get that in. That's a bit painful if for every text view you're having to add an additional function, getString resource. So what we're going to do is just kind of create utilities around that. So create a composable text that takes in an ID as opposed to taking a string piece of text. So there's a couple use cases there, and obviously as we go through that getting production ready phase, we'll build in that support. So, you know, again, as the team gets into it, you know, they can just hit the ground running. They don't have to worry about building that as they go. And then the last one is just team training. So as I said in the beginning, there is a fair amount to learn and a fair amount in kind of just changing paradigms. So what I would suggest, if you guys are implementing it, make sure that the team that you're working with is on the same page when it comes to Compose. Okay, so now I'm moving into once we've kind of got all of those standards defined. So we're looking ideally here at, you know, August of this year. Jetpack Compose has been released. It's on version 1. Essentially what we're going to do is, you know, all new screens that we create will be in Jetpack Compose. And as I mentioned earlier, if we're updating an existing screen, we'll just take it by case basis. So obviously just balancing between, you know, not creating more tech debt for ourselves and actually delivering on schedule. So we'll have to take that with a pinch of salt. And then finally, old work migration. So one of the things that I think is really key as guys move over to Compose is try to get your entire project into Compose as soon as possible, because just judging from previous migrations that we've done, for example, migrating from RX Java to Kotlin coroutines, it's very tricky for guys to handle, you know, 2 different ways of doing the same thing. And as time progresses, as people get more and more into Compose, they'll start to forget things around, you know, the old view layout, XML layout structure. So the sooner that you can get everything over to Compose, you know, the easier it is for your team's kind of cognitive load. I experienced kind of the same thing with converting Java to Kotlin. You know, if you don't get everything over to Kotlin, there'll be something that you don't touch very often that will eventually break, and you'll have to go back to it, and you'll be like, but I don't remember how Java works. Why is my variable in the wrong place? You know, that sort of thing. So the sooner you can get the migration work over, the better it is. Obviously, that's going to depend on a project by project basis. For us, we've got a 20% allocation of our time for tech debt. So we'll be utilizing that to migrate all of the things. And that's pretty much it. Thank you very much, guys. And if you got any questions, just give me a shout.
Brilliant. Thanks very much, Justin. That was great. Yeah, I think sounds like a really good approach and well thought through. Yeah, really good migration strategy. Question from Ian: have you considered using the adapter provided by Material for easier theme migration with XML?
Yeah, I took a look at that. It was quite a while ago, so I don't remember offhand the reason why we didn't take that approach, but we had just kind of said that we want to kind of look at it almost as if it's a new project, but it's not really a new project. That and there's certain updates that we want to be making to our theme at the same time as we're kind of implementing it. So yeah, we decided to just stick with, you know, without using the kind of adapter method and just do it kind of the native Compose way.
Cool. Any questions from anyone else? Cool. Yeah, I guess we're all good. Thanks a million to everyone, especially Justin and Stephen. And yeah, we'll post the link to the recording on the Meetup page. Thanks.
Thanks,
Thank you.
guys.
Bye-bye.